Hello, we were discussing the Astable multivibrator. I have already explained the working. So in this circuit we know that Astable multivibrator or relaxation oscillator, or we can call it as a square wave generator. Okay, the output of the op-amp depends on the differential input voltage here. This is works as if a positive feedback. I'm giving positive feedback here. This works as if a comparator. Okay, so it compares the voltage at the inverting and non-inverting terminals, and depending upon the differential input voltage VID, we are getting the output. The output usually switches in between the positive saturation and the negative saturation. That is, when the voltage VID is greater than 0, then the output will be plus VSAT, and it will switches back to minus VSAT when the differential input voltage VID is less than 0. When VID is less than 0, means that the voltage in the inverting terminal is greater than the voltage at the non-inverting terminal. So since actually in this circuit we are not providing any input, but the input the voltage across the capacitor acts as if we are giving an input. So as the voltage across the capacitor increases and decreases, the output switches from plus VSAT to minus VSAT. So let me explain the working once more. That is, when in the starting condition the voltage across the capacitor is equal to 0, and when we are turning on our supply plus VCC and minus VEE here, then what happens? Because of the impedance difference, here there is a potential divider circuit, there is a capacitor. Because of the impedance mismatching, there will be some offset voltage produced across the output, and we assume it as a positive voltage, that is VOO, output offset voltage will be produced at the output. So this will be fed back to the input from the positive terminal, or positively fed back that voltage V reference. Okay, the voltage across the capacitor VC is equal to 0, but V reference is equal to R2 divided by R1 plus R2 into VSAT. R2 divided by R1 plus R2 into VSAT. There is no beta here. Okay, so R2 divided by R1 plus R2, that is beta. So beta VSAT is fed back here in the reference input. So at the first stage, when I am comparing here the capacitor voltage is 0, but there is a small offset voltage beta VOOT. Because of this, the output will remain switched in plus VSAT state, or the output will be in the positive saturation state, and it will remain in this positive saturation region until the voltage across the capacitor is less than this V reference value. So when this value is plus VSAT, what happens? This is a higher potential and this is 0 potential, so current will start flowing from the output towards the capacitor, or the current will flow through the resistor R and enters the capacitor and leaves to the ground. As a result, the capacitor C charges and the voltage across the capacitor VC increases. So when the voltage of the VC is greater than this reference value, then naturally the voltage VID becomes negative, that is VC becomes greater than V reference. So VID will become negative and the output switches back to minus VSAT. That is, here when it reaches up to the capacitor charges and when it reaches up to the V reference, then what will happen? The V reference will be equal to my capacitor voltage Vs is equal to V reference. When it becomes greater, then naturally the op-amp switches back. That's why the op-amp switches back to minus VSAT. So in the negative state, what happens is, here now the capacitor is in minus VSAT, so the reference voltage changes to minus VSAT. Okay, minus beta VSAT, that is minus R2 divided by R1 plus R2 into VSAT, or V reference become minus beta VSAT. Now it will continue, the output will continue to be in minus VSAT until my inverting terminal becomes more negative than minus beta VSAT. ഇവിടെ ഉള്ള നെഗറ്റീവ്, ഇവിടെ ഇപ്പോൾ മൈനസ് ബീറ്റ വിസാറ്റാ, അതിനേക്കാൾ നെഗറ്റീവ് ആകണം, എന്നാലല്ലേ ഇവിടുത്തെ മൈനസും കൂടെ ആകുമ്പോൾ പ്ലസ് ആവത്തുള്ളൂ. അതിനേക്കാളും നെഗറ്റീവ് വോൾട്ടേജ് VC യിൽ വന്നാൽ മാത്രമേ ഇത് സ്വിച്ച് ആവത്തുള്ളൂ. അപ്പോൾ എങ്ങനെയാണ് soon after when my V out ഈ V out എന്ന് പറയുന്നത് മൈനസ് വി സാറ്റ് ആകുമ്പോഴത്തേക്കും വാട്ട് ഹാപ്പൻസ് ഇവിടെ എന്താ ഇവിടെ വി സിയുടെ വാല്യൂ ആണ് കൂടുതൽ സോ കറണ്ട് വിൽ സ്റ്റാർട്ട് ഫ്ലോയിങ് ഫ്രം ഹയർ പൊട്ടൻഷ്യൽ ടു ലോവർ പൊട്ടൻഷ്യൽ സോ ദ കറണ്ട് വിൽ സ്റ്റാർട്ട്സ് ഫ്ലോയിങ് ഫ്രം വി സി ടുവേർഡ്സ് ദ റെസിസ്റ്റർ ആർ ആൻഡ് ഇറ്റ് വിൽ ഫ്ലോ ടുവേർഡ്സ് ഔട്ട്പുട്ട് okay when the output becomes minus V sat so which means that when the current flowing out of the capacitor means the capacitor discharges so when the output becomes minus V sat the capacitor discharges through the resistor R and it will reach the value 0 then what will happen again the same current flow will be there so the capacitor charges in the negative direction when the voltage across the capacitor becomes more negative than V reference then the output will become positive that is when the capacitor reaches minus V reference then the output will switches to plus V sat so automatically the output here will be plus V sat here it will be minus VC so what happens it discharges the current was flowing like this now the current flow will be in the opposite direction that means here the negatively charged potential is discharging negatively charged capacitor is discharging that is why the negatively charged capacitor is discharging and it reaches 0 then it charges in the other direction in the positive direction this will continue and whenever there is a plus VCC and minus VEE supply this will continue whenever there is a plus VCC and minus VEE supply so even in the absence of the input waveform this astable multivibrator is creating a output waveform so we call it as a free running multivibrator it is a free running oscillator or an astable multivibrator or a relaxation multivibrator so astable multivibrator has two stable states and the time period for this stable state depends upon the voltage across the capacitor okay or the time period in which this input on stage and off stage depends upon the charging and discharging time okay so how can we design this RC network here the voltage across the capacitor is given by the equation VC at a time t is equal to final value plus initial value minus final voltage into e raised to minus t by RC this t is the time and the present time v of t and this RC is the main time constant capital T okay so I have rearranged this equation and I can write it as VC of t is equal to V final into 1 minus e raised to minus t RC and V initial I have taken in the front okay now we are considering t by 2 time period that is from minus beta V sat to my output is switching to plus beta V sat so at t by 2 my output voltage is plus beta V sat okay so VC of t is equal to final value is saturation value V sat minus initial value that is minus beta V sat into 1 minus e raised to minus t RC I am substituting this in my equation and finally I got beta V sat is equal to 1 plus beta V sat minus beta V sat so this beta V sat and beta V sat I am just simplifying it and I finally get it as 2 beta into 1 plus beta is equal to e raised to minus t by 2 RC this t is the present time t by 2 okay and I am simplifying it and finally what I get is e raised to t by 2 RC is equal to 1 plus beta divided by 1 minus beta first we solved it and we got it as e raised to minus t by 2 RC is equal to 1 minus beta divided by 1 plus beta so in order to we are making the inverse so that we are getting e raised to t by 2 RC is equal to 1 plus beta divided by 1 minus beta e raised to exponential so we are solving it by taking the natural logarithm so taking the natural logarithm we know that here it was e raised to t by 2 RC so natural logarithm becomes t by 2 RC and here natural logarithm means ln into ln of 1 plus beta into 1 minus beta so natural logarithm I got it as t by 2 RC is equal to ln of 1 plus beta by 1 minus beta what we have to design is the time period or the frequency so time period is equal to 2 RC ln 1 plus beta divided by 1 minus beta in order to take the frequency, we can make it f is equal to 1 by t like this. Okay, now